Okay, so today my name is Benjamin Siate, and today we are going to look at adders and multiplexer. That is the fundamental digital circuit of adders and multiplexer. We said that digital circuits are the building blocks of digital systems, enabling various operations like arithmetic and then data selection. That is the calculation of data. So now let's look at adders. Adders. When we say adders, what does it mean by adders? We said adders are digital circuits that perform arithmetic addition of two or more binary numbers. They perform two or more binary numbers. Okay, when we say binary numbers, yeah. So there are three types of adders, but we are going to look at two of them. We have half adder and then the full adder. Half adder adds two single bit binary numbers, and then full adder adds three single bit binary numbers. And we also have the ripple carry, that is ripple carry adder, a chain of full adders that are two multi bit binary numbers. But today we are going to look at half adder and then the full adder. So let's take half adder. Let's take the half adder first. So when we say half adder, we say that a half adder is a digital circuit that add two single bits binary numbers. So the truth table below will tell us how we add these two binary numbers. So the A and B, that is the input of A, which is 0, and then the input of B, which is also 0. When we are adding, that is, let's say, an AND gate, then it means that when these two inputs are low, low, they will give us a low as outputs when we add them, these two binary. In the same way, when you take find the first, this A input is 0, and then the B input is 1, which is the high. It gives us a high. So from the look of things, we can see that when both are low, they give us a low outcome. When both are high, we get a low outcome. But if one is low and one is high, we can get a high outcome or a high output. Yeah. Now let's look at a full adder. When you say a full adder, what does it mean? A full adder is a digital circuit that adds three single bits binary numbers. And then the table below shows how the outcome, the input, the A here is the input, and then B here too is the input. Then it gives us C as an output. Then we have a selector X, that is 0, 1, 1, 0, 1. Those are the selectors giving us an output of 0. So when we combine these three single bit binary, this will be the outcome, the output for the full adder. Now, the logic equation for this uh, truth table is the sum, which will be equal to A plus B plus C, will give us an output of A dot B, or in a bracket, plus A dot C in plus B plus C in. So that will be the equation for the logic equation for this full adder. Now let's talk about a multiplexer. When we say a multiplexer, we said that a multiplexer is a digital circuit that selects one of several input signals and forward it to the output. So it's a digital circuit that selects one of several and input signals and direct it to a single output line. That is what we are trying to say. So types of this multiplexer include 2-to-1 multiplexer, that is which we select one of two input signals, And then 4 to 1 multiplexer, select one of 4 input signals, and then 8 to 1 multiplexer, select one of 8 input signals. So we will be looking at the 2 to 1 multiplexer so that we can use it to explain more. Let's look at the 2 to 1 multiplexer. When we say 2 to 1 multiplexer, what does it mean? We mean that a multiplexer will select one of 2 input signals based on a select line. So the S in this table is the select line, and then A is the input, another B also an input, giving us Y as what? An output. Okay, so the logic equation for this will give us X. The X will take X, which is the selector, will take one input of A, that is X multiplied by A, plus the same selector X will take an input B, which give us a high input, and A give us the low input, giving us Y as an output 0, which is low. So that would be the equation. So if you see here, we have 2 to 1 multiplexer. We have 0 as a selector, 0 as a selector here, and then A, the input also 0, B, input 1, giving us an output of what? Y. Let's look at how this multiplier is applied. So we said that adders and multiplexers are used in various digital systems, including arithmetic circuits, data selectors, and then digital computers. So multiplexers are used to select one of several data sources. Data routing. Multiplexers are used to route data from one source to multiple destinations. Digital switching. Multiplexers are used in digital switching applications. So these are some of the uses of a multiplexer. So now in conclusion, we said that adders and multiplexers are fundamental digital circuits used in various applications. Understanding their operations and applications is crucial for designing and developing digital systems. Okay, so that is that for today. Thank you.